So you're just making this crap up. And apparently he didn't figure out that you can't change the length of the lever, so I was wrong about that. Somehow he didn't pick up the obvious fact that you can't change the length of the lever.
1 meter, well, it takes longer in the case of the ½ kilogram that's twice as far from the
So he's saying it takes longer is the same thing as saying it moves slower. There's no evidence it moves any slower. So again, no experimental evidence indicating any of that fucking happens. So just lie.
I've shown this before, but after your recent moronic outburst, I thought it might be worth showing again. So this is a lever with masses placed very close to the pivot points. The lever weighs 35 grams, each mass weighs 40 grams. I'll raise it to the vertical position and then let it go. The only force acting on it is gravity. So just raising it vertically and then letting it go. So just bear in mind this is a visual demonstration. It's not a touchy-feely one. And as you can see, it moves quite fast. So now we have exactly the same lever, the same length, with the same masses on. The masses are just placed much further away from the pivot points. Again, I will raise this to the vertical position and let it go. Same forces acting on it. As you can see, when I'm turning it here to get it to go vertical, it's much more difficult. The turning force is greater. And as we let it go, we're almost there. And now you can see visually, not touchy-feely, that the lever is moving a lot slower. You could time it. If you time 10 oscillations for both, this one actually takes more than twice the time to complete the same amount of oscillations. So no touchy-feely here, a nice visual, physical demonstration of what happens in reality.